Let's compare confidence intervals and hypothesis tests. So here I have a confidence interval for a proportion in StatKey, and I have randomization test for a proportion in StatKey. So I just picked proportions because I think they're a little quicker to work with, but the same principles apply to means as well. So when we have a confidence interval, I decided that I was working on a problem where I found 35 out of a sample of 90 to have said yes to whatever question I asked them. So 35 out of 90, and that gives me a proportion of approximately 0.389. Now, when I do a confidence interval, I have this data here, and if I generate one sample, my bootstrap sample, you can see that it's going to come up a little bit different than my original, but somewhat in the same ballpark. And if I continue to do this, I'm going to get different values, such that if I generate many resamples, remember these are bootstrap samples or resamples, so it is not my original, I'm going to generate this large curve, this sampling distribution. If I go over to my randomization tests here, I'm going to go ahead and do the same thing. I generate one sample at a time. Same principle applies. I'm generating just kind of a few numbers. Now you'll notice a lot of these numbers are quite a bit farther off from my original sample than the other one, which is interesting. We'll look at that. But if I generate a few thousand of these resamples, I get the same basic idea. I get this curve. So both the confidence interval and the hypothesis test, the randomization test, create a sampling distribution based on the original sample. Now, one difference between the two, if you look at the center here, I see the center is 0.39. 0.39 corresponds to my original sample proportion. So my original sample's center is the center of the sampling distribution. Over here, I see that the middle is 0.5, nowhere close to my original sample proportion. The reason for that is that the curve is centered around whatever my null hypothesis is. So if my null hypothesis is that the proportion is 0.5, that's what ends up in the middle. It shifts the whole curve. If I change this to 0.6, you can see that it'll actually move the entire curve. So if I generate a bunch of resamples here, you can see 0.6 is now in the middle of this sampling distribution. So they both have the sampling distribution from the original sample, but it shifts it over in the hypothesis test so that the null is in the middle. Now going back to what you do with both of them. With a confidence interval, you want to start with the probability. So let's put on the two-tail, and we're going to set the probability. If I want a 90% confidence interval, I type in 0.9 in the middle, and using the proportion from the center, I can figure out how much my interval should span each way. So from 0.3 to 0.478. That would be the confidence interval of the proportion. Going the other direction on the randomization test, we start with what was my sample proportion. So I'm going to, just for comparison's sake, I'll do two-tail again, and I'll set the proportion down here to be 0.389. So I set the proportion, and then I figure out what is the probability. Now, in this case with 0.6, it's actually a very, very low probability that you are going to find your original sample data. If we had a different null hypothesis, you can see that these proportions are going to change. So just generate a couple of these, do a two-tail test, and let's adjust this to be our original sample proportion, 0.389. And when I do that, again, I get a proportion. So with the confidence intervals, I set the part of the curve that I want to keep in the middle, and then I get my endpoints. Here, I set my endpoints, and I get what fraction of the curve is left out on the ends. In the confidence interval, I'm focusing on the middle, so many percent. On the hypothesis test, I'm focusing on the ends. So hopefully that gives you a few different things to compare and contrast between a confidence interval and a hypothesis test.